We will learn about the numerical methods. Okay, so the first method is Gauss elimination method. If we have given some problem like this, that is x minus 2y plus z, y plus minus 2z, 2x plus 4y minus 3z equal to 3, then solve the system of linear equation using the Gauss elimination method. That means we have to solve this equation. That means we have to find the values of x, y, z using the Gauss elimination method. Okay, so let's get started. So in Gauss elimination method, what we have to know, that is we have to first find out the augmented matrix. Augmented matrix means A and B is written together. That means here we can write the matrix A as, what is the matrix A? In the form of Ax equal to B, the matrix A will be the coefficients of x, y and z. So the first row will be 1, minus 2, 1, and then the second row will be 0 because here there is no coefficient for x, and the y coefficient is 1, z coefficient is minus 2, and here for the third row the x coefficient is 2, y coefficient is 4 and z coefficient is minus 3. And now Ax equal to B, that is the unknown variables. There are three variables like x, y and z, and Ax equal to B, and B means what? The constant, that is this 4, minus 4, 0 and 3. So minus 4, 0, 3. So the first step of Gauss elimination method is we have to write this equations in the form of Ax equal to B, that is Ax equal to B. Now we have to find the augmented matrix. Augmented matrix is simply we have to write this matrix together with B. Okay, so now we have to deduce this according to the row operation. That means we have to find the upper diagonal matrix. That means upper diagonal matrix means that is there will be this diagonal, and below the elements we have to make it as 0. So for that we have to find the elementary row operation. Okay, so first we have to write the augmented matrix, then we have to reduce it to an upper diagonal matrix using the elementary row operation. So elementary row operation means we can interchange any two rows, or we can multiply all the elements of any row by a constant, or replacement of a row by that row plus a constant times another row. That means we can see in this example. So this is an example of the previous question, that is we have to write the augmented matrix. Okay, so this is the augmented matrix, that is AB. So we have wrote here. Okay, so this is the augmented matrix AB. Now we have to, next step is this, that is this is the diagonal elements 1, 1, minus 3. Below that we have to reduce it to 0. That is, we know that here it is 0, but the 2 is not 0. Then how we can reduce this 2 to 0? We can write the operation as R3. So this is in third row, right? R3 gives, so the R3 gives R3 minus 2 is there. So we have to multiply 2 into R1. That is, we know that the R1 value is 1. Okay, so R3 is 2. That is 2 minus 2 into 1. That means 2. That means we can make it as 0. But we have to change all these elements, all the third row elements. So 4 will be replaced as 4 minus 2 into the element will be here. R1 is minus 2. Corresponding R1 is minus 2. So 4 into minus 2 into minus 2, that means 4 plus 4, that is 4 becomes 8. And minus 3, the R3 is minus 3 minus 2 into, and R1 is what? 1. Right. So minus 3 into minus 3 minus 2, that is minus 5. And 3 will be 3 minus 2 into minus 4. That means we will get 11. Okay, so here we will get we got like this, that is these elements became 0, but here also we have to make it as 0, that is we have to make this 8 as 0. For that we can write it as, divide the third row by 8 and replace third by third minus second. That means first of all we can divide this third row as by 8, that means 0, 8 by 8 1 minus 5 by 8. So whatever elements, whatever operation we will give to a row, we have to completely use that elements. Okay, we have to completely give all those elements the same operation. So minus 5 by 8, 11 by 8. Okay, 11 by 8. Now what we have to do is we have to subtract R3 gives, we have to change the R3 element, right? R3 gives R3 minus, here is 1, right? So we can just write R3 gives R3 minus R2. Okay, R3 minus R2, that means 1 minus 1, 0. Now 11 by 8 minus 5 is R3, minus 5 by 8, right? Minus 5 by 8 minus R2 is minus 2, right? Minus 2, that is plus 2. That is minus 5 plus 16 by 8, that is 11 by 8. And here also we will get 11 by 8. Now what we can do? So this is in the form like we have reduced it. Now x into 0 plus y into 0 plus z into 11 by 8 equal to 11 by 8. From that we will get z equal to 1. And here we have to back substitute. That is y into x into 0 plus y into 1 minus 2 into z equal to 0. And z value is 1. Right. So y equal to 2. Knowing the z and y value, we will get the value of x from the first row. Okay, so that is the back substitution. So here we have done the Gauss elimination method. First we have to write the Ax equal to B form, then augmented matrix, then the raw operation. Okay, thank you.